Okay, so hello, my name's Ross. Again, I do tutoring on the west side location. Hopefully the location will open soon. My last recording was this TABE M reading on graphs and maps, and you can see it up here on the top right of the graph. It's TABE M, reading graphs and maps, and I did pages 89 through 95. So we did a bar graph. We practiced on a circle graph. We did a line graph. We did some questions on this bar graph here. We read a map. We did some practicing on this map with the legend, which is this little part down in the bottom left of the map. And then we talked about distances between US major cities in this mileage map. So we're going to start on page 96. And we're going to do a checkup on this map. So we have questions 1, 2, 3, 4, and 5. So why don't I just, you can pause it and try 1 through 5 on your own if you want. If you do want to do that, you can pause and do it on your own, and then we'll go back after you unpause it. Remember, this is your video, so you can fast forward, you can watch it twice, you can watch part of it and then come back to it. It's up to you. So go ahead and pause if you want to try on your own. All right, so what I normally do again with maps and graphs and things is just take a minute and look at the map and see what I'm dealing with. So I see, okay, this is looks like a mileage map because we've got some mileage down here. It's of Olympia, Washington, which is a city. It's got the legend down here. So you've got interstate highways, you've got a US highway. A point of interest is a black square. So that's somewhere that the map maker feels is interesting. Here is a compass, north, south, east, west. All right, let's look at the questions. What city is the focus? So see, just because we took a minute to go and kind of look at the map, we already know the answer to this. It's going to be Olympia. That's our city. What direction is Olympia from Lacey? So here's Olympia. Here is Lacey. So which direction is Olympia from Lacey? So it is to the west, right? It's to the west of Lacey. Is Olympia from Lacey? So if you're going from Lacey to Olympia, you're going that way, and this way is west. What river does Interstate Highway 5 cross? Let me get rid of, well, we could probably keep them in there. Interstate Highway 5 is this thick black line up at the top. So it crosses over the, looks like the Indian River right here. So that would be my guess. It crosses over the Indian River. About how many miles is it from Martin Way to Log Cabin Road? So you're going to have to do a little bit of looking. So if I switch my drawing tool here to, let's do yellow. Martin Way is, where are you, Martin Way? To Log, well, here's Log Cabin Road. Here's Martin Way. So about how many miles? So let's do this. So we're going to have to kind of guess. It would be better if this was on a piece of paper, but my guess is, if I'm doing this right, it's probably like 2 miles would be my guess, because you can see here, this is what a mile is, and this line, if we could grab the line and move it, my guess is it's going to be 2. It says about how many, not exactly. So it's either going to be 1 or 2. My guess is it's going to be 2. And then last, what direction is Little League Baseball Park from Chambers Lake? Here's Little League Baseball Park. and then Chambers Lake is this thing right here. So what direction is Little League Park from Chambers Lake? So you're going to be going this way. So if you do that, you're going southwest. Hopefully I'm doing that right. It says, what direction is Little League Baseball Park from Chambers Lake? I'm thinking it's going to be southwest because that's the way that you would walk. You'd walk southwest to get from Chambers Lake to Little League Baseball Park. So hopefully those matched up. If you can try it again, that's fine too. Let me erase my drawings and then we can move on. So what we did was we did our checkup on this map of Olympia, Washington. Okay. So the last thing on this packet is a reading. So it says read the channel under the sea, then answer the questions about graphic information. So this is page 37, 38, 39, and 40, and then a little bit more here. So it has a few questions about England and Europe, and then it has using graphs and maps here as well. And then that's it. So I'm going to kind of lead here. I'll zoom in, and then you can probably just pause it and then read it on your own. And then I'll scroll down to the next page as well. So this is the kind of the second page. We're doing stuff about the shuttle design and dealing with problems. And then our last paragraph, the way to go. So let's start with over here on using graphs and maps. So you can pause it and write these down. You can grab a piece of paper and try to answer them. Some of them look like they're written response, and then a few of them are multiple choice. All right, so this first one says, this article tells how much the channel was expected to cost and how much it really cost. If you made a bar graph, how many bars would you need? How would the bars be labeled? Where would you have to place the dollar figures? Now that you have decided on the design, draw the graph using labels where they are needed. So this says, again, it tells how much the channel was expected to cost. and how much it really cost. If you made a bar graph, how many bars would you need? So we could kind of draw one over here on the side. If we have our pencil, we're making a bar graph. So remember, bar graphs kind of look like this. We've got bars here. It might look like that as a bar graph. So all we're doing here, I can tell, is that this says it tells how much the channel was expected to cost and how much it really cost. I would say you would need 2. So if we set up our, let's say this is our piece of paper here, you would need a bar, you would need 2. How would the bars be labeled? So I would say this would be expected cost, and then this would be real. How would the bar, where would you place the dollar figures? So you could put it here. This would be the dollar, right? You would say, what was the cost on the other page? If we go up, the cost was up here, wasn't it? So it says it was expected to cost 7 billion and it cost 16 billion. So 7 and 16 are our numbers. So expected, so what you would do is you would maybe you do 5 billion, 10 billion, 15 billion, 20 billion. And remember, these charts you have to be consistent with the units that you're using on the left-hand side. You can't do like 5, 8, 16, 34, it has to be the same units. So if you're going to do 2s, you do 2, 4, 6, 8, 10. If you do 10s, 10, 20, 30, 40, 50, you could do 50, 100, 150, 200. You just want to be consistent. You should notice that in graphs how they're very consistent with their units, how much they jump. It could be 1, 2, 3, 4, 5. So ours is 5, 10, 15, 20. So the expected, I think, was 7. So between 5 and 10 is like 7. So you would say the expected would be here. And then it was 16, I think. So 16 is about here, right? So the real would be right here. So it says draw the graph using labels where they are needed. So this would be in billions. And you can do it way different than this. But that is how I would do it. It would be nice to have a piece of paper, so maybe you have one, but that's how I would do it. 2 bars, the expected cost, and then the real cost right here. So number 2 says, which of these topics would be best shown in a circle graph? The order of events in building the channel, how the total cost was split up, how the cost of the project grew year by year. Well, order of events probably would not be the best for this. And let me clear off the stuff here and we'll pick another color. Order of events just doesn't make sense for a circle graph. So let's do a nice circle graph here. So ordering of events, I don't know how you do it. You have like 1992, this happened. 1996, this happened. So I don't know how you would put that in a circle graph. Probably not the best. How the total cost of the project was split up, that one probably makes sense. And then how it grew year by year would be probably a good one for like a line graph. We've seen like the line graph would be like this. So this would be the year, like 95, 1996, 1997. This would be good for a line graph like this. So I'm saying it's going to be B, how the total cost of the project was split up. So maybe you have, you know, what is that? 25% would be labor, and then maybe 33% is materials, and then, you know, whatever that is, percent is, I don't know, some other cost that goes into the channel. So I think a circle graph would be the best for splitting up. On a map, find London, Paris, and the English Channel. Use the scale to find. Well, I don't know how we're going to do that one. You can, if I were you, you can Google it. Just pull up Google and then go find that, London, Paris, and the English Channel. And then there should be a scale on the map that you can find. And you could find the shortest distance between London and Paris, and then the distance across the English Channel. And then you can look at a map again. You know, let's see. I bet you we can find here on our own, right? If we do Google and then we scroll out, let's get rid of our tool here. And it said for us to go to, if we scroll over to London. So this said London, Paris, and the English Channel. Use the scale to find the shortest distance between London and Paris. All right, so I don't think we'll be able to do this 100%, but here's London, here's Paris. Shortest distance, right, would be this. And then on your computer, try it out. I don't see a scale because I think that I might be blocked by the GoToMeeting thing here, but you can use a scale, and then you could have a ruler or something like that, and then it will tell you, like maybe this, for example, would be 100 miles. So you would sort of estimate 100, 200, 300, 400, 500. So just as a guess, I mean, I have no idea what it is, but that's how you would use the scale. There should be a scale. Maybe this is a scale down here. 20 miles. Maybe that's it. So let's say 20, 40, 60, 80, 100, 120. So maybe our guess would be 140 miles. And again, that's just a guess. I'm not 100% sure. But that's how you would do it. Let's erase. And then it says, look at the map. Why has there been little, if any, talk about building a tunnel from England to the Netherlands? So you would have to do England to the Netherlands. And you know, if you're not sure where the Netherlands is, you can always type it in here, Netherlands, and then it highlights it for you. So it says, why hasn't there been much talk about another channel from England to the Netherlands? Well, look at the channel here. I mean, from England to France, I don't know exactly where the channel is, but that is very short. If you want to go to the Netherlands, look at the distance here. I mean, that's too long, too far, right? Too far. So that's why there hasn't been much talk of a channel or a tunnel from England to the Netherlands. You might even say that maybe this is closer here, or maybe here to here. That could be kind of closer, but not as close as this. I mean, this is way close, super close. So it's a good idea to do these. You know, it's nice to go through and look at a map and see if you can figure it out. So then we have some review questions over here. And it says, in what ways is England part of Europe? And I remember that from the part right here. So it talks about it here. In one sense, England is part of Europe. English history is closely tied to that of Europe. The music and art have strong links. English also trades with all of the nations of Europe. What fears stop people from building a tunnel sooner? What were the fears? So we have some of the fears over here. People's fears. So armies might use a tunnel to invade. Other worry that a tunnel would help the spread of disease. Hey, speaking of spread of disease, right? Right now we're living in the COVID world. So others worry that a tunnel would help the spread of disease. Maybe it has. Maybe it has, right? What were some of the problems that the builders of the tunnel faced? So this is good practice for you. If your reading gives you headings, then it's great to go and look. What were some of the problems? Well, it tells you right here. There was heat. Builders had to put in air conditioning. People worried about floods. Fire is another problem. There's no breeze. So that was some of the problems. What have builders done to make the tunnel safe and comfortable? Again, they're dealing with problems, right? So safe and comfortable. We kind of talked about that. They added air conditioning. The tunnel walls are made of reinforced concrete. Automatic doors slam shut to contain any fire, and then they put a spray on the fire. So they've thought of everything, it sounds like, for that one. And then the last, how is travel by tunnel better than travel by air? And I remember that one from down here. This is the paragraph here. It talks about it. How is traveling by tunnel underneath the water better than air? Well, airports are far from the centers. When you go by air, you could have a flight delay. You can be across the channel in 35 minutes if you take the tunnel. The passenger train only takes 3 hours from London. So those are some reasons why that taking the tunnel is better than traveling by the air. So that is the end of this packet. We looked at today. We didn't do a ton today. We looked at this map of Olympia, Washington, and then we talked about the tunnel under the sea, and we went on to Google Maps here, and we did some looking at the tunnel. Let's see if it tells us where the tunnel is. Maybe this is it. So here we go. This kind of tells us, and we kind of were right. If you see, it sort of was like here. So they kind of picked the closest spot to do the tunnel, which makes sense to me. All right, well, we'll pick another packet next week or whenever the next time it is that we meet, and I'll stop the recording, and hopefully I'll see you guys down the road for another recording. Thanks so much for listening. Have a great day, everybody. Bye.